Prefix lists and BGP. The use of prefix lists, it's not limited to BGP, but you're going to use it with BGP a lot. And a couple of reasons Cisco likes to list for that on their website. There's high flexibility, support for incremental updates, and here's the really good one that you're going to love the more you work with BGP. Writing BGP prefix lists, it's much more efficient and easier than writing ACLs that filter BGP updates. Because BGP tables, they can have thousands of entries. They're going to be much larger than any IGP table you work with. And the thing with prefix lists, they of course are matching on what? The prefix of the address. And therefore the overall process is much faster than using ACLs. Great thing is when you're learning prefix lists, especially this is the first time you've ever seen them, they have quite a few things in common with ACLs. They work just about the same. Prefix list, if a route is not expressly permitted, it is implicitly denied. At the bottom of a prefix list, as well as an ACL, we have that implicit deny, and explicit deny statements do not override the implicit deny. I know you know that from ACLs, but I'm just letting you know the same thing is true of prefix lists. The operation is much the same. Prefix lists work from top to bottom, and when you find a match, the process stops. So we know that the lines have to be in the right order in order to do the job that we want the prefix list to do. Now, let me adjust that a little bit. Okay, thanks. Now, prefix list lines are numbered by default. This is a wonderful thing, and I'm going to work this into the lab because the lowest numbers are going to be at the top, and even if you and I don't enter the statement numbers manually, the iOS is going to do it for you, incrementing by 5. And the reason I like this so much is because I actually go back to those dark days where, with an ACL, if you wanted to add a line to the middle of it, you had to rewrite the entire thing. You couldn't just put a sequence number in there and have it automatically appear in the middle. This really makes it so much easier. It's much more efficient to go back and add lines exactly where you need them. And I'm going to work this in at the end of this lab. And here is this lab, by the way. We've got router 5 over there all by itself, and it's connected to router 1, or communicating with router 1, I should say, over the 10110/24 network. And routers 1, 2, and 3, just as in the route reflector lab, are an AS 1, 2, 3. Router 1's the peer, and routers 2 and 3 have internal peerings with router 1, but not with each other. On router 5, I already have 5 networks advertised. I have the usual loopback, all 5/32, and I have 4 other networks, so let me go ahead and bring that up. And besides the fact that I'm showing you the number that it's router 5, we've got quite a few clues here that we're on the router of origination for these networks. First off, the next hop being all zeros, and then the weight being 32,768. We know the route was locally generated or locally created. Now, and in case you didn't draw the network out, probably have this one memorized by now, but let's go to router 1 and then 2 and then 3, but I want you to tell me now, and I'm listening, I promise, that whether each router is going to have those entries, period, and if it has those 5 entries, will they be marked as valid and best? Because that's the first thing we got to do before we do any prefix list. We need to make sure everybody's seeing the routes that we think they ought to see. So we will first bring the rack back up. We moved one thing. You move one thing and it just messes you up. So let's do a show IP BGP sum. We're moving to a new workspace here, so everything on the table is just a little bit different. So we've got all our adjacencies here. That looks good. And we've got show IP BGP. And all the routes are valid and best. Next hop 10.1.1.5. Everything looks good there. You also see the AS path here under path on the far right beginning to grow, because instead of just having an I, we have a 5 and an I. Now, will routers 2 and 3 have these routes? And if so, will they be accessible? Will they be valid and best, I should say? And it looks to me like it's telling us what? That they are valid but not valid and best because of that next hop rule. We know that's a problem. And then on router 3, show IP BGP, you can see what's going on here. Next hop 10.1.1.5, and we know that if we put, say, show IP BGP 5555, that's going to say inaccessible. So we know that is indeed a problem. So let's go up to router 1. What's a good solution for this one? What would you do? I would do next hop self. That's a good solution for that one. or BGP 123, neighbor 172, and next hop self, and then we'll do a 3 right there. And that likely resolves our issue. Let's check that before we start working with prefix lists. And you can see they're all marked valid and best. The next hop has indeed changed to 123.1, and both 2 and 3 know where that is. They're directly connected to it. And there we go. So we're all set there. Now the word has just come down from on high, as it does at work sometimes, that we would like routers 2 and 3 to not know of the existence of the 16, 17, 18, and 19 routes. But we do want it to know about the 5555 network, and we'd like it to know about all networks that are added to router 5 and advertised by router 5 in the future. Question's getting a little more complex there. That's more of a CCNP lab / CCIE thing. We've got some requirements. We want to see certain certain networks. We don't want to see other networks, and we've got to do a little planning for the future here. The first problem that we need to solve is where to put a prefix list. Now, if we were told, and of course we want router 1 to have all the routes. That was the other requirement. Neither was something else. So going over the requirements, we want router 1 to see all networks advertised by router 5. We want routers 2 and 3 to see only that one loopback 5555 and any networks that are added in the future. Well, that kind of disqualifies router 5 from being the place we put the prefix list. Because if we start blocking routes being advertised from 5 to 1, right there we're violating one of the requirements. We want router 1 to continue to see all 5 networks that it's seeing now. We want routers 2 and 3 not to see all of them, so a good place to put the filter here, actually the only place to put the filter, would be router 1. So let's head up to router 1, and we're going to write a prefix list. And the command to do so is IP prefix list, and you got to give it a word, a name, and then there's a sequence number, include, exclude sequence numbers, and we're going to leave that alone. So we're just going to call this net5. We'll keep it short. And deny description permit sequence. You know I love descriptions when you're writing ACLs, and the same thing goes with prefix lists. Just write a little description saying, here's what this prefix list is for, because someone may come in after you, 2 years from now, and you've moved on, you've gotten promoted because you took my courses and you got certified. Congratulations on both. And the thing is, they're looking at it, and maybe they didn't take my course, or maybe they don't know, or they're looking at it and thinking, what is this prefix list here for? What's the purpose of it? And it's a great thing to leave, is to leave somebody a clue as to what a complicated prefix list is for. This one's pretty simple, so we're not going to add a description to it. And now, let's go ahead and do a deny. And you can see the IP prefix network /length EG 35000/8. And I'm going to put 1600/8 for my line. And notice that it rejected my line. I hate to even insult you by saying, do you see why it rejected my line? But I'm sure you do. It's that space. It's real easy to do, but the network and the slash and the length, it has to be one. You can't leave a space on it. That's why the caret is actually pointing to the empty space right there. So let me back it up a little bit. Not the first time I've ever been told that, and we'll just do a little back spacing here after doing an up arrow. And I'll put in an 8 here. And I will put in a 9 here. And if we leave this prefix list as it is, what then is the net effect of this prefix list? It blocks everything, because the explicit deny statements that we've put here do not do anything about the implicit deny. So the first line is deny network 16, second line is deny 17, third line is deny 18, fourth line is deny 19, fifth line that we don't see but we know is there is deny everything. So we need to put in the prefix list equivalent of a permit any statement. But we don't have the option to actually type in permit any. So we have to know exactly what goes here, and this is a great thing to memorize until it becomes second nature to you, is to permit 0000, or permit 0, not quite done yet. You need an LE here, I believe iOS, yes. Great minimum prefix length to be matched greater than or equal to. The LE is less than or equal to maximum prefix length to be matched. And what we're going to do here is put an LE, and then we're going to put the maximum prefix length, which is 32. So this is a prefix length equivalent of the ACL's permit any, and it's permit 0000/0 less than or equal to 32. Matches everything. Of course, if you make that the first line, then you're permitting everything because the other lines would never be read. So that is the end of our prefix list right there. Now we need to get them applied. We're going to apply them at the beginning of the very next video, and then we're going to add another network and see if we can throw an extra little monkey wrench into things. I'll see you on the next video. We'll take it from here.